From this diagram, we will see the matter is classified as the mixtures and pure substance, and mixtures again subdivided by the homogeneous mixtures and heterogeneous mixtures, and pure substance is classified again by the elements and compounds. So now what is the pure substance? While all constituent particles of a substance are same in chemical nature, then it is said to be a pure substance. But the mixture contains particles of two or more pure substance. That means mixtures come from the mixing of the two or more pure substance, and which may be present in it in any ratio. So their composition is variable. That means in mixture the composition is the variable composition, whatever you can mix with two or more pure substance. Pure substance forming mixtures are called its components. That means in mixture, whatever component is there, that is made of the pure substance, and this pure substance is called its components. Many of the substances present around you are mixtures. As for example, sugar solution, the very common solution. Sometimes with lemon we used to take it in water, and air, it is mixture of several types of elemental gas. That be nitrogen, oxygen, carbon dioxide, so many. And regularly whatever we used to take the tea, that also mixture. And then this mixture may be subdivided by the homogeneous or heterogeneous, whatever I already told in during the explaining the diagram. So now we'll see what is the homogeneous. In a homogeneous mixture, the components completely mix with each other. As for example, the sugar solution. This means the particle of components in a mixture are uniformly distributed. These two words we have to remember, throughout the bulk of the mixture, and its composition is uniform throughout. So in the homogeneous mixture, the components are completely mixed with each other. This means that particles of components of a mixture is uniformly distributed. These two words we have to write. Throughout the bulk of the mixture, and its composition is uniform throughout. That word uniform also very important. Example, whatever I already told, the sugar solution, air are the example of the homogeneous mixture. In contrast to this heterogeneous mixture, the composition is not uniform. That means in homogeneous it is uniform, the composition is uniform, but for heterogeneous the composition is not uniform. And sometimes different components are visible. That means whatever the components are there in the mixture, you can visualize this. For example, you can see if solid salt and sugar, grain and pulse along with some dirt, that means some stone piece, if you mix, then immediately you can visualize this is this mixture is the heterogeneous, and different components are visible. The components of a mixture can be separated by using physical methods such as simple hand picking, filtration, crystallization, distillation. That means simple hand picking you can do. If their grain and pulse with stone is there, then you can hand pick the stone. In that way you can separate the mixture. And another examples, especially for the homogeneous mixture, we have to use the filtration, sometimes crystallization and distillation. That means in the water and salt solution, if you distill, then you will find the salt after evaporation of all water. Pure substance. Pure substance have characteristics different from the mixtures. What is the difference? The constituent particles of pure substance have fixed composition. Example, copper, silver, gold, water, glucose are all examples of the pure substance. We are talking about water and glucose as a different. It is not the mixture of the glucose in water. Then it will be the mixture, homogeneous mixture. But in this case, water and glucose individually, they are the example of the pure substance. Contains the carbon, hydrogen, oxygen in a fixed ratio, and its particles are of same composition. Hence, like all other pure substance, glucose has a fixed composition. Also, its constituent carbon, hydrogen, oxygen cannot be separated by the simple physical method. So that is the difference from the pure substance from the mixture. Mixture you can separate by the physical method, but pure substance you can't separate in this way. The pure substance can further be classified, whatever we already discussed, in elements and compounds. Particles of an element consist of only one type of atoms. These particles may exist as atoms or molecules. We'll give the example now. As for example, the sodium, copper, silver, hydrogen, oxygen, etc. are some example of the elements. Because they are all atoms are of one type. That means copper's atom is different from the silver, and it is different from the hydrogen, different from the oxygen. The atoms of different elements are different in nature. Some elements such as sodium or copper contains atoms as their constituent particles. Whereas you think that other things, here example already there are hydrogen and oxygen, natural hydrogen and oxygen. In some others, that means in this particular case, the constituent particles are molecules which are formed by two or more atoms. As for example, whatever I already told, the hydrogen, nitrogen, oxygen gases consist of molecules in which two atoms combine to give their respective molecules. So here one figure is there. You can visualize this, that hydrogen, oxygen, nitrogen, copper and sodium, these all are the elements, atoms of different elements. But when the one atom of hydrogen add with the, normally it will not add, it will go for bonding with another atom of hydrogen. Bonding will know the later. Then one molecule of hydrogen will be formed. Similarly, one oxygen atom and another oxygen atom will form one molecule of oxygen. That means O2. When two or or more atoms of different elements combined together in a definite ratio, the molecule of a compound is obtained. We'll give the example. So here one thing clear, that the constituent of a compound cannot be separated into simpler substance by physical method. And that is the difference between the pure substance and mixture. Pure substance, you cannot be separated the constituent by the physical method, but in mixture you can do. So what will happen for the separation of the constituent of the pure substance? They can be separated by chemical methods. For mixture by the physical methods, and for the pure substance, the constituent you can separate by the chemical method. Example of some compounds are water, ammonia, carbon dioxide, sugar, etc. A water molecule comprises 2 hydrogen atoms. Next slide, we'll see the figure of it, and 1 oxygen atom. A molecule of carbon dioxide contains 2 oxygen atoms combined with the 1 carbon atom. So if you see the figure, then you can see that here is the 2 hydrogen atoms react with the oxygen atom to form the water molecule, and similarly 1 carbon atom react with the 2 oxygen atoms to form the carbon dioxide, CO2. And for water molecule, the formula is H2O. So the atoms of different elements are present in a compound in a fixed and definite ratio. In case of water and in case of carbon dioxide, what we already told, that 2 hydrogen atoms react with the 1 oxygen atoms to form the H2O or water molecule, and similarly the 2 oxygen atoms react with the 1 carbon atom to form the carbon dioxide. So those compounds constituents is in a fixed and definite ratio, and this ratio is characteristics of that particular compound. That means we'll give another example, that H2O, when 2 atoms of hydrogen react with the 1 atom of oxygen, then water will form. But when we'll see later that 2 hydrogen atoms react with 2 oxygen atoms, then it is called the hydrogen peroxide. Hydrogen peroxide. This is the hydrogen peroxide and this is the water molecule. So that means these compositions, what is the ratio is there? H2O atoms ratio 2:1, that is the characteristics of water molecule. But when the 2:2, meaning 2:2 ratio for the hydrogen and oxygen atoms, then it is the characteristic of the hydrogen peroxide. That means another compound. So also the properties of a compound are different from those of its constituent elements. We'll see one good example is this, that for example the hydrogen and oxygen are gases. Whether the compound formed by their composition water, it is the liquid. Moreover, one interesting thing is there, you can find. It is interesting to note that hydrogen burns with a pop sound, and oxygen is the supporter of combustion. That means it is helping the combustion. But water is used as a fire extinguisher. That means hydrogen and oxygen independently can create the fire, but the molecules by combination of 2 hydrogen atoms and one hydrogen atoms, which is the water. This is used as a fire extinguisher. So that is very interesting. You can visit my podcast also as the Dr. Acharya Academy in Google's for the chemistry. Now I started the chemistry in honors.